Hi, I'm Lindsay and this is Anthony, and today we're going to talk to you about using expression animations to create engaging and custom UI. If you're unfamiliar with the visual layer, we'd recommend pausing this talk and going and watching Tim and James's talk on Beautiful UI before you get started here to make sure you have the appropriate context for this one to be useful.
Okay, so before we jump in, let's take a look at expressions and actions so you'll have a little bit more information of what we're talking about here.
So let's open up a little app we have here. And we notice as I pan this app, there's a whole bunch of animations happening all together. This makes the UI a little bit more exciting. It's less static. As a user, it's more interesting. You can see that as I transition down, we get to keep some context of where the picture's going, where the name is, everything like that.
Right, so you'll notice in the app, as we move back and forth, things are happening kind of all coordinated. There's all these moving parts on screen. You see the image shrinking and hiding behind the top panel. The top panel has a blur effect that's being applied to it, but everything seems to be nicely choreographed relative to how much I'm actually panning the content on screen.
So let's take a look at how we're actually doing all of this.
Okay, so in the visual layer, we offer two types of animations. We have keyframe animations, which allow you to animate from a starting value to an ending value over a duration of time. And what's nice about them is you can do things like apply an easing function, and we'll use that information to interpolate the value every frame to get you to your final position. Now, all of our visual layer animations run independently of your application's UI thread. So we do this because performance is a big deal for us, and we want to make sure your apps look the best. And so for us, making things fast and fluid is paramount. So while this is good for your app for keyframe animations, it does present some challenges for other type of scenarios.
Right, so like Anthony mentioned, keyframes are kind of fire and forget. And if they're running independently of your app's UI thread, it can be kind of difficult to make sure all the things are happening in a coordination that you like in your application's process. So for this type of scenario, we introduced expression animations. Expression animations, rather than being time-based, are reference-based. So you're going to go ahead and be able to reference properties of other objects on screen and use that as the driving factor for your animations. And it basically allows a lot more coordination, like what we saw in that first demo, where it would have been pretty difficult to preemptively declare all of that with keyframes and make sure they're moving together. So let's take a look at a hello world expression to kind of see what we're talking about. So here we have a little sample app, and we see that this red square is animating from something happening in our application, and the blue square right now is completely static. So what if we want the blue square to move with the red square? Well, we could try and figure out a keyframe that, apply the same keyframe to both of them. If we want to do something similar but a little different, we can try and figure out the right keyframe to make that happen. But what if we, check out what expressions can do and see how it's a little easier to get that flexibility? So let's go ahead and hook up an X offset animation to our blue square. Now, we can see that the blue square is moving with the red square completely together, frame over frame, in sync. So let's take a look at how we did this. If we look at the sample code here, we see that first we create an expression animation off of the compositor. Then we hook up what our actual expression is going to be. In this case, we say look at others X offset and apply 20 additional pixels to it. So then we have to tell the expression what other actually means. So then in this next line, we're telling the expression that other is going to mean red visual. So we're going to look at red visuals X offset, add 20 pixels, and then what do we do with that? That's where the next line comes into play. We hook it up to blue visuals X offset. So all we're doing here is saying that no matter what is happening, blue visuals X offset is going to be red visuals X offset plus 20.
Right, and so what's really powerful about this concept is no matter why red visuals offset X is changing, blue offset will react to that change and it'll run this expression. So in this case, we're running a keyframe animation that we're looping through, and it's applying a nice easing function, and things are lockstep. If I were to directly set the value of red visuals offset X, blue visual will jump right to that value at the same time in the same frame on the system side.
Another thing that you may notice is here we're calling start animation. This is pretty similar to what you do with a keyframe too, but one distinct difference is that expression animations don't have a finite start and stop the way a keyframe does. They do have a finite start, but once you hook them up, they're going to change any time that the properties they're referencing are changing. So until red visual goes away or we explicitly stop the animation, we will always mirror the same value.
Right.
Another thing that you may notice is that the expression is actually a string.
Right. So you might be thinking, hey, I thought strings were bad. You know, what's going on here? Well, in this case, strings are good. They're very good, and let me explain why. So what we're doing is we're taking this instruction that you're giving us, and we're running it on your behalf, independent of your UI's thread. So you don't have to worry about any interruptions that are coming from your app's logic, fetching any data. But in order to do this, we need to give you a way to be able to describe what you want to happen. So instead of creating like this really heavy new object model with all these reinventing the wheel with how to describe operations and parameters, we said, well, just type it up in a string. We'll take it, we'll check it, and we'll execute on your behalf in the system compositor.
So let's take a look at an example that's a little more involved. Here we have a bunch of gears on screen.
So as you can see, the gears are moving nicely in sync, nice and smooth. Now notice the first gear, the red gear, is actually being operated by keyframe animation. So think of it as like the motor that's driving the series of gears here. But every single gear, subsequent gear, is actually moving with an expression animation.
So let's take a look at what code you have to write to hook something like this up. So first, we're basically on page load. We're setting up our gears. All we're doing here is taking all the XAML images and getting the backend composition visuals. Then we go through this for loop for each of our gears. We configure gear animation based on a gear and its previous gear. So let's go check out configure gear animation and see what's actually happening. In configure gear animation, just like we did in our Hello World example, we're creating an expression animation. In this case, our expression animation is going to reference previous gear, rotation angle, and degrees. So basically, rotation angle and degrees is a property on a composition object that you're able to reference in your expression. So in this case, we're just saying, look at this composition object, take its rotation angle and degrees, and negate it. Then we have to tell it what previous gear is going to be. So we take previous gear as passed in to configure gear animation. Then we hook it up to current gear using our same start animation call and declaring that rotation angle and degrees is what we're going to be animating. So really all this is doing is saying, look at the gear right before me, take its rotation angle and negate it, and apply that to me. So every single gear is just flipping from the one before it. And because of the way gears work, that happens to give us this great effect where all the gears are rotating off of each other, basically.
Right. Now imagine having to do this with a bunch of keyframe animations on screen, and if you wanted to change that, it would be very difficult to do. You probably couldn't even pull it off with the type of smoothness and dynamic behavior that you would expect.
Right. So by just changing the speed of that initial keyframe or the direction of that initial keyframe, all the others change together for free.
Yep.
So back to our slides.
All right, so the expression that we used in the demo there was pretty straightforward. All we did was look at the previous visual's rotation angle and negate it. And a lot of times, that's all you really need to do with your expressions. They're usually pretty short and pretty concise. But there are times when you need to do a lot more, and we recognize that for certain interesting motions and behaviors. So to help facilitate some of these things, we offer a whole host of operators and functions and constructors for you to use. So you can do things that you would normally be accustomed to using with C# or C++, like adding, subtracting. We have a bunch of helper functions like absolute, clamp, lerp, teradians, and you can even create new objects or define new objects inside your expression. So you can say, I want to take the x value and y value and create a new vector2 from these two arbitrary values or properties, and then you can take it and apply it to your target.
Another thing we've added in expressions is we've basically taken the word this and reserved it as our keyword. This allows us to basically pick particular functions, or not necessarily functions, properties that we think developers will commonly want to reference. And this lets you guys basically get access to some stuff that we think makes your expressions even better. So for example, this .starting value is one of the most useful ones we can think of. Basically, what it does is it lets you get the value of the property you're animating at the time the animation begins. This can be really useful because it makes it so that you can just reference the starting value and do something with that rather than having a jump to some particular value that you have to pick up front. This makes it easy to get smooth transitions as soon as you hit start animation. In addition, this .target takes that to the next level. This .target lets you access the object that the property you're animating is on. That basically means that you can access any other property on that same object and reference that in your expression as well. So these can be pretty powerful, especially if you want to coordinate a lot of different things based on all kinds of changes happening on screen. We're always looking for to expand this. So right now, this is just a small subset of what we offer. And if you check out MSDN, you can see a more complete list.
Right. If there's something missing that you're finding yourself doing often, let us know and we can consider adding it in a future release.
OK, so let's take a look at a few more samples so that we can see how to actually take advantage of these other operators that we've just talked about. Nope. So if we go back to our same example from before, and we switch over to see a color animation, let's take a look at what this one does. So we see that we're passing in a threshold and 2 colors, and using those in our expression below. So what we're doing here is we're looking at visuals offset, we're comparing it to a threshold, and changing color based on that threshold. This actually is pretty cool because it shows off the ternary operator, which is one of the more powerful operators you have at your disposal in the expression string. So what you can do here is basically set these parameters just like we've done in our other Hello World type sample. And then we go ahead and actually start the animation. And in this case, we're going to animate the brush rather than the visual because we're looking at changing the color.
So something you'll notice here, in addition to setting the reference parameter, which, by the way, each expression should have at least one reference parameter. Because without it, then it's really going to resolve down to a constant value, which means it won't animate, so you might as well set the property directly. So, but you're not limited to just one. You could have as many as you want. You can have 2, 3, 10, 100, 1,000. Please don't do that. But you could have as many as you like. But in addition to that, you see us actually calling set scalar parameter, set color parameter. But why are we doing this? So those aren't reference parameters. Those are really just for placeholders that we have defined in our expression. You'll notice we have threshold, color 1, and color 2 defined in our expression. And what this allows us to do is to create an expression and kind of reuse it as in a helper function. And then at the time that we actually apply the expression to the target, we'll take those color parameters that were defined or set using set scalar parameter and set color parameter, and we'll swap them out in the expression.
Right, so in this case, we happen to be flipping between green and purple, but we could put any other colors and reuse this other places in the application if we wanted.
Yep.
So let's take a look at another example. So in this case, we see that similar to last time, our red visual, or we have one visual who's animating side to side. But in this case, we see that the blue visual is actually taking the X animation from the red visual's offset and using it as a Y animation.
Right. So this is something we like to call swizzling. So if you're familiar with like shader languages like HLSLs, it might be a familiar concept to you. But it turns out it's actually quite useful even outside of writing your own custom pixel shaders. So what you can do here is say you can reference subchannels of more multi-channel properties like a vector 2, vector 3, or a matrix 4x4. And you can pick out which ones you want, and you can swap them around as you're describing them. And you can even swap around as you're targeting to the target property that you want to apply the animation to.
Right. And so one thing in here, in this example, we happen to be applying XY from red to YX of blue. But we could animate blue visuals X property and Y property completely independently. Here, we happen to be targeting the same animation, but we could just as easily have completely different animations, and they would still be in sync, frame over frame, X and Y updating at the same time, and completely independently of each other.
Right, so it's pretty cool. You can actually have like an expression that targets the X channel and a keyframe animation that targets the Y channel. But by the time every frame, they get resolved and they get applied to the right destination. And so if you have any of the other expressions that are referencing that entire multi-channel component, they will get the right value, the combination of those two animations that were applied to those individual channels.
Right. And in this case, we happen to be targeting channels of offset. But like Anthony mentioned, you can do it with anything, including subchannels of effects and things like that. So you can get some pretty cool visual animations going. So let's head back to our slides. One other particular feature that we wanted to talk through is property sets. We've talked a lot about references so far, but so far we've talked explicitly about referencing properties from a composition object. So composition objects have a set of properties that you'll be able to reference. But if you want to do something a little more unique, a little more flexible, property sets are your best friend. Property sets let you basically populate some property set or property using application data or anything you want, and then reference that in your expression. So in this case, the application decided that the hour of the day is going to be important for the expression. So they have some external logic that's getting the hour of the day and populating something called the hour in the property set. Then we can see we set up our expression just like we have everywhere else, and we use a ternary like we did in the previous example to see whether the time of day is between 6 a.m. and 6 p.m. And if it is, we'll go ahead and use light blue. And if it's not, we'll go ahead and use dark blue. This is pretty powerful because it lets you get a customized experience. In this case, maybe during daylight hours, we have a lighter glow going, and at nighttime, we have a darker glow going.
Yep. So think of a property set as like the new and improved property bag of the old days. And what's nice about property sets is that typically you can only target composition objects like a visual or a sprite or a container. But a property set allows you to create your own object with its own schema that you create and have it participate in the calculation of expressions that are running in the system compositor on your behalf. And what's nice about property sets also is that you can actually animate the values. So you don't have to just set them directly. I can actually target animations to those values. And then if other expressions are referencing those properties in my property set, they will get updated accordingly.
Right. So property sets basically are your way to get even more flexibility to customize the experience to be right what you want for the look and feel of your application.
Yep.
So next, one of the things we've done a lot is talk about how there are all these different, flexibility points and features available to you through expressions. But one thing we haven't touched on yet is the fact that you can actually use expressions directly in a keyframe as well. So we're going to go back to our gears example and see why this could be useful. So if we look back, we never actually looked at the keyframe we were using to animate that initial gear. So we can see here just from looking that it's an expression. But what happens if we look at what happens with a more basic keyframe? So here, it's pretty straightforward. We're going from time 0 to 1, and we're going from 0 degrees to 360 degrees. So we just want the gear to rotate once.
Makes sense,
makes
yeah.
sense.
Yeah.
So we go ahead and get started.
Okay, so it was stopped. We started it. It looks great. Everybody's happy. Until we stop it again. You notice when we resumed it, it jumped. And if we keep hitting these buttons, you see it like doing this jitter, abrupt stop and start over again. And I'm pretty sure that nobody wants that. So how do you solve it? It's kind of difficult because the value in the compositor is not the value you're seeing. So there's no way for you to know the exact value at the time that you start your animation until now.
So if we go back and look at the animation that we were using before, we notice that it's an expression. And we're using one of those keywords we mentioned earlier, this.starting value. That means we'll go ahead and take the starting value at the time the animation begins and add 360 degrees to it for the ending state. So no matter what rotation the gear is at, we go from that point and add a full rotation. This makes a lot of sense for this example because we don't want the gear to jump back to 0 degrees every time. We just want it to keep spinning at the new speed.
Right.
So if we go ahead and recompile our app and take a look.
Okay, so now if we stop it and start it, it picks up right where it left off, nice and smooth. And if we keep hammering on fast or slow, we see that there's no jerkiness. It's nice and smooth and picks up right where it left off.
So that's one example that kind of just gives you an insight into where this can be useful. So we've talked a lot about kind of the actual feature set and what you as a developer can call from the API, but we haven't touched on some of the inside workings or tips and tricks that can make sure you get the best performance out of your animations and make sure you're using the system as best you can. One thing we want to call out, if we go back to where we were configuring our expression for all the gears, here, every time we're referencing the previous gear. One thing that's kind of cool about the way the system works is you don't need to worry about what order you're referencing different things in. We resolve all of that for you. You can call them in any order you want, however you want, and we'll make sure to resolve them and that everything gets done the way it should.
Right, and if you create a circular reference, we'll figure out the best thing to do on your behalf, but it won't crash your application. It certainly won't crash the system. but we'll try to figure out the best thing to do in those circumstances for you. So something else, you'll notice that in this example, we have the our expression that we're using to apply to the gears, the M rotation expression. We only create it once, and then we reuse it over and over again. So why are we doing this, and why can we do this? Well, this is recommended if you have an expression that you're going to be using in multiple places in your app. You're probably better off creating it once and then reapplying it to all your targets. And the reason you can do that is because all of our composition animations, so whether they are keyframe animations or expressions, they're actually templates. What does this mean? So this means that if I take this animation and I configure it, I apply it to a target, we actually read the data from that expression or from that keyframe animation, and we copy it and then send it on its way down to the system compositor to execute on your behalf. If you were then to go up to that keyframe animation and change a value, like insert a new keyframe, it has no effect on any running animations. So that's one thing. That's really nice. With expressions, same behavior, but it's even more of a benefit is that whenever we go to take that expression and apply it to the target, there's a little bit of work that we have to do before executing that animation. So we have to make sure that the expression is valid, is it balanced, do the types resolve the way you expect them to, or have all your references been resolved. There's a little bit of work we have to do up front. And so if you know you're going to be reusing your expression, you create it once, and then you can just reconnect it over and over again, and you skip that step on subsequent connections with that expression.
Right. So having the use of templates and knowing how to use them can really save you some extra perf work. In addition, another thing that can be really useful is leveraging property sets. We talked about these earlier, but it was through the lens of them being a way for kind of flexibility and referencing data. But the other thing you can use them for is actually some performance benefits. For example, if you have the same complicated operation happening in a variety of expressions across your system, you can actually have that operation performed once, place it into a property set, and reference that value from all the other animations. This means that when we go to actually evaluate all of your animations, each frame, and decide what to do with them, for each frame we'll only have to do that one once instead of every single place that you have it in an expression. So this can also just be a good way for you to make sure you can get as many animations running as possible at 60 frames a second. So that's all we have for you today. But if you liked everything you saw, you can definitely go check out these samples and more on our Team GitHub page. This is a great place to see some samples that are a little bit more UI-centric, like that initial one we showed at the beginning of this talk, as well as a lot of other things available in the composition namespace. You can also follow our team on Twitter and get updates from us on new samples we're releasing, SDK drops, all that kind of stuff. We love hearing from our developers, so definitely come reach out to us.
Yeah, let us know what you're up to.
And if you're interested, definitely go listen to some of the other talks on Build that the Windows UI platform team is doing. There's a lot of great ones. Thanks.
Thank you.